This event will be recorded and we will share it at a later date upon request. With that, the agenda is we'll start with quick welcome and introductions. I'll actually run a pre-survey because we want to get some of your input. We want to kind of know who you are and why you attended today, what you hope to gain. Professor Zhang will start with a welcome message, and then we'll go right to our sponsors. Dr. Geetika Joshi will speak from the CDFA, Guangwei Huang will speak on behalf of the Almond Board, and Denise Molinex will speak on behalf of the California Dairy Research Foundation. Then we will go to Aaron Wickstrom, who is our collaborating dairy for this project, who will talk about sustainable dairy operations. We'll have a Q&A for those first speakers, and then in the second hour, we'll have a couple of research presentations by myself and Dr. Sat Darshan Khalsa, and then Q&A, and we'll finish it off with a survey, another post survey, and some closing remarks. And with that, we'll initiate the poll. So you all should see the poll launch, and feel free to answer questions. Some of the questions are specific to farmers, and you can click does not apply. Once you answer all the questions, the window should go away. Looks like everyone is answering. I'll just let the poll go. As you finish it, the window should go. And I will turn it over to Dr. Zhang.
Hey, good morning. Yeah, I'm Rui-Hong Zhang. I'm professor in the Department of Biological and Agriculture Engineering. And I wanted to thank you for joining us for this important field day, virtual field day. And so I wanted to welcome you, and also want to tell you a little bit about our project and the research we have been carrying past 2 years. And this is for a 3-year project, and we have 1 more year to go. Hossein, next, please. So this is a research to apply the compost and pelletize the compost products from dairy manure and almond woody biomass in California almond orchards. I wanted to thank sponsors for this project. Is the California Department of Food and Agriculture, California Dairy Research Foundation, and the California Almond Boards of California. Next, please. Well, in this research project, we have this goal to basically to take the dairy manure and woody biomass from almond processors and create valuable compost products. And the compost products include the loose compost and also pelletize the compost. And so we have been able to compare the two. And so with the achieve what the benefits we wanted to achieve include environmental economic benefits, and they include carbon sequestration and recycling carbon nutrients back into the soil, and certainly creating jobs. And then we have 3 objectives for this research. And so the research part is the first 2 objectives. So we'll be presenting later in this field day. And so the first objective is to characterize the physical and chemical properties of dairy manure and almond woody biomass compost products with and without the pelletizing. And the second objective is to investigate and demonstrate the effectiveness of these compost products in recycling carbon, providing nutrients, improving the soil health in the almond orchard. And so the third objective is to conduct these outreach activities. And certainly we're planning to publish and convey our results to our stakeholders and to the public. And today's field day serves for the third objective, and this provides us with the opportunity to share some exciting research activities we have been carrying on, also share some of the research results we have so far. And this is our second year, and we have one more year to go. And so we are planning to have more field days and one in the fall. Hopefully by that time, we'll be able to do in person. Next, please. So I wanted to acknowledge the researchers involved in this research. And so our research team consists of multidisciplinary investigators. So I want to start to acknowledge the co-PIs for this project. And Dr. Hamedi El-Mashed, and who's a staff researcher in my department of biological and engineering, and Professor Patrick Brown, and also Dr. Sasha Kansan. And so they are from Department of Plant Science, and Dr. Frank Mitterluner from Department of Animal Science, Dr. Pramad Pandey from Department of Population Health and Reproduction. And also wanted to thank the researchers involved in this project, and they include Dr. Yuka Chen, Dr. Tyler Barzi, and you just met Hossein Idalati, and also Alan Cho, and they are from my department and working with me in my laboratory. And also wanted to thank our collaborating the farms and Wickstrom Dairies. You will hear from Aaron Wickstrom, and he is a speaker on the program. And also wanted to thank JD Van Ruler, and who have been working with us in his almond orchards. And also a number of other collaborators from industry who have provided great work and collaboration with us. And so I want to thank them as well. Next, please. And so next, I wanted to introduce the speakers and from our sponsors. And first is Dr. Gedika Joshi, and she is speaking on behalf of California Department of Food and Agriculture. And Dr. Joshi is a supervising senior environmental scientist in the CDFA's Office of Environmental Farming and Innovation. And she is leading department's dairy methane reduction healthy soil incentives program. And I have, well, we have emailed you the bios of our speakers. So I'm trying to keep the introduction to brief. And so with that, I will turn our podium to Dr. Joshi.
Hey, good morning. Thank you, Dr. Zhang. I want to start by just congratulating you and your team on the research that you're doing and conducting this field day. And at the same time, I also want to acknowledge there are so many other demonstration project recipients as well. And in this pandemic year, the ability to conduct field days on farms has been so limited, and everyone has just kind of gathered together and come up with ways to do it virtually. And, we really applaud everyone for finding those types of solutions. So very quickly and briefly, I would just share that, this particular program, Healthy Soils Program, is housed within California Department of Food and Agriculture in our Office of Environmental Farming and Innovation. And this mission has, this office has the mission to serve California by supporting agricultural production, incentivizing practices that result in a net environmental benefit. And there are several programs that are housed within this office. Healthy Soils is one of them. We have our dairy methane reduction programs, alternative manure management, and dairy digesters. We have the State Water Efficiency and Enhancement Program, which incentivizes irrigation systems for water and energy savings. We also fund technical assistance providers who can help farmers apply for funding through these programs and also help them in implementation. And we have, additional programs on pesticide consultation, as well as fund research projects and work on international collaborations as well. And a unifying goal for some of these incentive programs is, climate change mitigation and reduction of greenhouse gas emissions. And these programs are primarily funded by California Climate Investments, which is our state's cap and trade fund and revenue. And in some cases, for instance, Healthy Soils Program, we've also received funding from Prop 68 in the past. And our programs have a strong arm of outreach, education, and engagement, along with working directly with farmers and ranchers to implement those on-farm solutions, which can be quantified. And that's the unique thing about California, is that we quantify all the greenhouse gas reductions. And then we also conduct, verifications and evaluations to kind of monitor these types of funded projects. You can go to next slide, please. I just quickly wanted to share specifically about our Healthy Soils demonstration and alternative manure management program, as both of these projects have provided funding for different aspects of this project in Dr. Zhang's lab. The Healthy Soils program has incentives, which are directly funds for farmers and ranchers, and demonstration funds, which are for nonprofits and universities and RCDs to implement eligible healthy soils practices and conduct education and outreach. And today is one such field day that's funded through the demo projects. And this program has funded till date over $40 million to 646 projects. And I have some numbers on the greenhouse gas quantifications, and then kind of an equivalency to help us visualize what that number means. So over 100,000 metric tons of CO2 emission reductions that are equivalent to almost 100 acres of forests. And the alternative manure management program is a separate program for dairy and livestock operations specifically, and it funds manure management practices that are not anaerobic digesters, but that can help reduce methane emissions. And methane being a potent greenhouse gas is a strong focus of state funding for greenhouse gas mitigation. And for that program, we funded $68 million to over 160 projects that reduce about over 200 tons of metric tons of CO2 emissions every year. And so again, some numbers from these programs, we have shared some photographs that shows examples of the kind of practices that are funded through these programs. And we have also funded many technical assistance providers, as I mentioned, to help farmers apply for this funding and to help them implement as well. So with that, I will just leave it at that. In this current year, we are still waiting for the July 1 state budget to find out if we're going to have more funding for Healthy Soils and AMP. That's a question that we keep getting often. So we are also waiting for the legislature to take action on that funding. And yeah, with that, I will just conclude the remarks from here. And thank you very much for having me over. And if there are any questions about any of the CDFA programs, please let us know, and I'll be happy to answer them. Thank you.
Thank you, Geetika. And our next speaker is Guangwei Huang, and Guangwei is Associate Director for Almond Board of California. And he directs and manages research in almond quality, safety, and processing technology, and co-product utilization, harvesting technologies. And so he also conducts trade education events and food processing outreach activities for Almond Board. Guangwei, please.
Thank you for the introduction invitation, Dr. Zhang. And great thanks to you and to your research team for carrying out a research project aiming to develop the solution for handling one of our almond woody biomass. Good morning, I'm Guangwei Huang. I like as a short introduction by Dr. Zhang. I joined Almond Board 2001, began to oversee research in food safety quality. And we only start up 5 years ago to look at figure out a better way to use the, biomass. We generated, over 2/3 of our volume is a biomass. So that we started 5 years ago to look into it. Almond Board really appreciate the California Department of Food Agriculture funding this project. We're really pleased to collaborate with the California Dairy Research Foundation to co-fund additional experimentation to this project. California almond industry produces 3 streams of biomass, hulls and shells, and woody biomass of tree removals, prunings, and sticks. The mass of hulls and shells, is proportional to kernel production, while mass of the tree removal will largely depend on the volume or acreage of remove each year. The tree prunings vary each year, and the next pruning have been done by growers in the orchards. But this leads to more sticks accumulated at the holler shallow site. The 3 streams of almond biomass are often handled as the disposable byproduct, leading to no returns for the industry. Hulls and shells represent about 70% of almond food weight, but only less than 3% of income generated from each harvest. So each stream, the biomass stream, has its own special properties that can bring significant value, but each stream also faces different challenges or competition requiring customized attention. In 2018, in elevate the value of the co-product, Almond Board of California Board of Directors set a goal to achieve 0 waste in our orchards by putting everything we grow to optimal use by 2025. Almond Board has invested in research to expand feed uses and other higher value potential explorations, has been actively promoting values or optimal use of the almond co-product. For the last 5 years, Almond Board has invested more than $2 million in searching for better or more ways to utilize hulls, shells, and woody biomass. There are funded research projects including expanding feed uses to lactation cows or chickens, or value-added exploration of hulls, uses of shells or torrefied shell in the plastics, shell-derived biochar in soil amendment, sticks in dairy manure compost, carbon sequestration or emission effects of whole orchard recycling, and so on. So almond woody biomass, including the tree removals from old orchards at the replanting, the prunings and sticks accumulated at producing orchards and holler shallow site. The feed of prunings and sticks at orchard or holler shallow site vary with a different situation, but they are primarily used for surface mulching or soil amendment or open burn. As ag waste open burning is being banned, our almond growers needed more ways or solutions to handle the woody biomass, especially for the tree prunings and sticks. The tree prunings and sticks, a rich carbon source with a good absorbing property that can play an important role in soil amendment or carbon sequestration. Mixing or composting ground sticks or prunings together with dairy manure is a unique integrated approach, as the woody material can capture minerals or nutrients from manure, then release them to the trees when they are needed. This CDFA project is a timely and important one to create solutions for local laboring almond and dairy farmers. This was why both of our organization jumped on this opportunity to co-fund additional work to this project. The project used the sticks from holler shallow, but the project funding are applicable to prunings generated in the orchard. So more sticks accumulate at holler shelter site, but the prunings can be spread over all the orchards across the Central Valley, including some remote areas that may be far away from a dairy farm. So our almond growers can definitely have more help from regulators and researchers to develop more open burning alternates for the prunings. I have heard some positive results from your previous report. I'm looking forward to learning more about the latest funding from the project and looking forward to working together with the research team and the collaborators to promote adoption of this integrated approach by almond or dairy farmers as a routine farming practice in the future. Thank you for your attention. If you have any question, I can answer now or maybe during Q&A session. Thank you.
Thank you, Guangwei. I really appreciate them. Yes, for the audience, if you have questions, you can type your questions in the chat. We can have our speakers to answer those as we go. Certainly, we will have a short QA session, and for questions that are not answered, we'll be able to try to answer. At least please feel free to type your questions in the chat. And so I wanted to introduce our next speaker, Denise Monlex. And Denise currently serves as a California Dairy, as a director for California Dairy Research Foundation. And she's also assistant director for California Dairy Quality Assurance Program. She has many years of experience in leading farm change, has worked in both the academic and the private sectors within the dairy industry. Denise, please.
Well, thank you, Dr. Zhang, and thank you to the team for all of the hard work. We too are very pleased to be part of the project and part of this morning's outreach effort. So for those of you who might not be familiar with the California Dairy Research Foundation and kind of who we are, just a little bit about us. We're a nonprofit and we manage the research and scientific education outreach on behalf of California's dairy industry. Our primary funding really comes from the California Milk Advisory Board through checkoff dollars from the dairy producers themselves. In addition to that, we get additional funding from research institutions, government agencies, and private industry. Back in 2019, the foundation really went through some restructuring and updated our strategic plan. And the purpose of that really was to focus in on addressing, I guess, more pointedly, the challenges that we're facing our California dairy industry today, and really facing all of us who live here in California. So, you know, those issues are air quality, water quality, and healthy soils. And so at that time, really what happened is now roughly 60% of all of our research funding is focused on sustainability issues and specifically focused in that environmental management area. And the bulk of that really is in and around what I would say manure management and improving that. Improving the techniques and the information available about that for our dairy community. So also back in 2019, we undertook kind of a foundation research project for us. And that was really looking and conducting an analysis of the manure that's produced here in the state by our industry, and looking at it more as a product and looking to our end users on how could we improve manure and manure-based products and the utility of those for those outside of the dairy industry. Obviously, within the dairy industry, we're using it as a fertilizer and a soil amendment and so forth. But I think it's long been known that manure is very valuable for the soils and for other crops that are grown here in the state. But, you know, we were aware that there's some challenges and there's some sometimes some barriers that are put up against the use of manure. And so we wanted to better understand those from our actual end users. So we conducted a very large study that went out to growers of all types, almond producers included, as well as those that serve you, the crop consultants and so on, to try and learn more about this. And really what we learned is that, you know, by and large, people like manure, they want to use manure, but there was some issues with it. People were looking for more of a consistent quality and a reliable quality type of product, something that was weed-free, something that was a little easier to transport and maybe utilize as part of their normal application pattern. And so this study for us really comes, on the heels of that. And it starts to take a look at a co-composted product, and specifically a pelletized product that might be of greater value to some of our end users. So we really saw this project as a nice way to be able to partner with some of our fellow ag organizations, with the Almond Board, with CDFA and the UC, obviously, and taking a look at this type of product. So we're quite pleased to be part of the study and quite excited for the results that we are seeing.
Thank
And
you.
with that, yeah, Dr. Zhang, I'll turn it back over.
Okay, thank you so much, Denise, and appreciate your presentation. And before we go further, and so we do have a pre-survey. We have seen more people joined us, and I would like to relaunch that survey, very short survey, so that our audience has a chance to go over. And you should be able to see the survey on the screen. If you can answer the questions quickly, now we'll resume our program. We appreciate their input and answer the questions in the survey.
Just a note, if you've been made a co-host, you won't be able to do the survey. Only guests will be doing the survey. So. I think as people continue that, we can continue with the program, and people will just finish.
Very good then. I just want to check.
Okay, sounds good.
Talk to you later.
Okay, so we'll come back to our speaker program, and I would like to introduce our next speaker, Erin Wickstrom. And Erin has been great supporter and a collaborator for our project, and I really wanted to thank him and his staff on dairy to make our research possible and a success. And Erin is a managing partner at the Wickstrom Dairy's LP, and his dairy is in Helmer, and there's a house 2,400 cows. So it's a big dairy, and Erin is a fourth generation owner of the Wickstrom Dairy, and he is a great believer in integrating technologies on his farm and farms to benefit their business, their animals, and the environment. And Erin, please.
Dr. Zhang, I appreciate the opportunity to share a little bit about our dairy and farming operation today. My name is Aaron Wickstrom. I'm managing partner with Wickstrom Dairies and Valsigna Farms. As you can see in the picture in the title slide here, our dairy is right next to an almond orchard. It's been one of the great things about this current project with the great UC Davis team we've got to work with is we get to work with our longtime neighbors, Van Ruler Orchards. So to be able to work with a world-class almond orchard operation like they have and collaborate amongst the two big industries in the Central Valley here, the dairy industry and almonds. It's been a great project, and we look forward to seeing the final data as it comes out later on. So a little bit about our operation. We were founded in 1940, so this year is our 81st year in business. We're currently milking 2,400 Jersey cows on our current main site that you can see from the picture. As you can see, almonds and dairies from this picture, that's pretty much what's around us. So it's great that we get to work with our almond neighbors on a daily and yearly basis. So to provide all the feed for those cows, we farm about 1,000 acres. We're able to provide 100% of our forage needs for our dairy, which has allowed us to do a lot of experimentation with healthy soils and soil health from year to year and be able to see the results on a large scale and gather that data internally so we can become better farmers and better stewards of our environment. So in our farming operation, we use what's called conservation tillage. We use a combination of strip tillage for our corn. So you can see on the picture on the left, we're only tilling a 12-inch strip every 30 inches. And then we plant our corn directly into that. So it's allowed us in the passage route where water is really cut back. It allowed us to reduce our water usage. We were able to extend the periods between irrigations longer than we normally would with traditional tillage. And we've seen a lot of benefits with increased earthworm populations in our fields and just overall healthier crops with less inputs. And then the other part of our crop rotation, after we harvest our corn silage, we go in right away behind the chopper with our no-till grain drill, which is the picture on the right. And without doing any tillage, we plant our Sudan grass crop that will grow for about 60 days, and we'll harvest 10 to 15 tons from that crop. And we will harvest that for silage or hay for our cows. And once that is harvested, once again, we go right in with our no-till drill and we will plant our winter forage crop, which is usually a winter wheat or triticale that we'll use for silage or hay. So it allows us to be really efficient in our farming operation. We've minimized our passes over the field to just 4 to do 3 crops. So not only has that been economically beneficial for operation, but it's also reduced our fuel usage, labor costs, and we've just seen overall better soil health, increased organic matter, and nitrogen holding capacity, which has really benefited our crops. So when we talk about sustainability amongst our team and our operation, we look at it as a multifaceted idea for us. So sustainability for us, our number one resource that we have is our great team I get to work with every day in the upper left-hand corner as one of our Christmas parties with our team. And without them, we couldn't dairy farm, we couldn't farm. So we got to make sure that that resource is sustainable. We take care of our team, and we take care of each other. After that, we have our cows. We need to be sustainable with them, how we treat them, provide them a great low stress environment so they're productive and have longevity as well. And then also we look at it as our air, water, and land. So we have a 5-acre solar farm. We're able to offset about 98.5% of all of our electrical usage on our dairy and farming operations, which has been really beneficial. And then also using precision irrigation and using conservation tillage. we've seen big benefits in just the productivity of our land, and knowing that it's going to be taken care of for following generations if they continue to want to farm going forward after I'm done. So overall, our approach, my philosophy, our family's philosophy, and our team's philosophy is we're stewards of these resources. They're not really ours, and it's our job to take care of them for the time that we are in charge of them. So I just wanted to say thank you for the time and allowing me to share a little bit of our operation today with you, and on behalf of myself and my family and our team here at Wickstrom Dairies and Vel Signa Farms, thank you, and appreciate your time. Thanks.
Thank you very much, Aaron, and thank you for all the great support. Aaron, and definitely is part of our research team, not just supporter, collaborator. And we also, besides this project, the Healthy Soils project, we also have one dairy manure demonstration project with Aaron. And so he's putting in a centrifuge, and he already has composting, and he's going to put in a big commercial scale pelletizer. And we hope to have a workshop or field day at his dairy later this year. And thank you, Aaron.
Yeah, we're looking forward to that. And lastly, just really appreciate the UC Davis team. It's been a great collaboration working with all of you over the years, and we look forward to our current collaborations and future collaborations to come. So thank you.
Thank you. Okay. We have a few minutes for questions, and I have seen question in the chat, and I can ask that question. And so the question is, when we use almond stakes or prunings, are there any issues with the contaminants such as plastic or other trash being introduced to the biomass stream? If so, how difficult is this to manage? And definitely we have encountered contaminants during our research, and in Jose's presentation in a few minutes, and he's going to address those. So, however, I would like to, if Guangwei, you're around, maybe you can provide some insight to this question.
Sure. Quickly, just definitely those, irrigation pipes, can get into the sticks pile. Those is really, I think when you get in, you had to really sort out. I guess probably your team had to encounter those issues. But I think in the future, let's move forward. It's an education issue. We have to, if we want to find, we have better use of those sticks, we have to just let the grower know. They had to do better preparation work before harvest, because we have a harvest practice guidance document. So they have to prepare the ground better. So before they shake the almond to the ground, they should remove those big pieces, like those big debris. So those can be managed. I think it's after done, if it's already getting the pile, maybe I had to do some manual separation. Yeah.
Thank you very much, Guangwei. And other questions from the audience? You can either put your question in the chat, or if you wanted to speak up, ask question, and please do so.
We have a question for Aaron from Elliot Grant. His question to Aaron is, how do you weigh the benefits of cover crop versus silage production? Do you only cover crop when silage needs have been met?
Yes, so that's the multi-species crop that we grew last year. We're still experimenting a little bit. There is still some silage value for dry cows with that cover crop. With the season last year, we planted our cover crop a little bit later than we wanted to. So we ended up terminating that crop and no tilling into it. but we look at it as some of our farms do have a higher clay content, and compaction at the end of fields can be issues after harvest. So we're trying to focus, several fields or one farm, one of our 4 farms per year, and doing a rotation in with the multi-species cover crop.
Okay, thank you, Aaron. Are there more questions? If not, we will move on. And thank you, all the speakers. And also, Aaron, just looking at your beautiful family, please give our best regards. Thanks to your family for working with us, and also the happy cows.
Yes, thank you.
In the photo, they're so awesome. And okay, we will go into next hour. We are going to focus on the research presentation, and I wanted to introduce our next speaker is Hossein.
Hi, everyone. I'm actually going to stop sharing and reshare my presentation.
Okay, so as Hossein bring out his research presentation, and I will introduce Hossein. And Hossein has been working with me for several years, and he is a PhD student in my department and my lab. He's just outstanding scholar, researcher, and he has been very interested and also has been leading the research on this project. So his interest has been waste management, nutrient recycling, and he has worked with all sorts of biomass and organic waste material, include the dairy manure and woody biomass, and also he has work on the food waste treatment. With that, Hossein, please.
Thank you. Thank you for the introduction. Several of you had questions that I think I will probably address a little bit with my presentation. The title of my presentation is Production and Application of Compost and Pelletized Compost Products from Dairy Manure and Almond Woody Biomass on California Almond Orchards. I want to again acknowledge the project personnel, the PI, Dr. Zhang, all the co-PIs, Dr. Satdar Shan, Dr. Patrick Brown, Dr. Pramod Pandey, Dr. Frank Mitloner, and Dr. Hamid El-Mashad, who are the co-PIs, and also Ika, Tyler, and Alan, who really we work together. I go out to the farm every time with Ika, and we, this is a pretty big project that we couldn't get done without us all working as a team. I get to have the fun of presenting it, but really it's the work of a lot of people. And obviously thanking all of our sponsors and collaborators. We've actually had a lot of industry collaborators on this project. We don't have tractors. We don't have front end loaders. We don't have all this big fancy machinery. And so we depend on the farmers and also the industry collaborators to help us get things done on the farm. So again, the project goal is recycling dairy manure, almond stick, twig waste on almond orchards as a nutrient-rich, safe, organic amendment which can sequester carbon and provide economical and sustainable benefits to the soil, crop, and environment. In my talk, I'm going to focus on investigating the on-farm composting of dairy manure and dairy manure co-composted with almond stick twig waste and the production of pelletized amendments from compost. The second objective is applying the loose compost and the pelletized amendments using a conventional orchard applicator and assessing the differences in amendment broadcasting and degradation. And I'll talk a little bit about that last part, the evaluating the amendment broadcasting and degradation. I'll mention the experiment briefly, but really I'm mostly going to get into the first year data and hopefully set it up for the next field day, which you all attend, and we're hoping in the fall. The third objective is to study the effects of these organic amendments on the soil and tree as it relates to soil physical chemical properties, pathogens and emissions, and also tree health, almond yield, and consumer safety. So what's the motivation for this project? Orchards need organic matter amendments and nutrients because they can increase water holding capacity, they increase resiliency to drought, they increase crop yields, and they decrease sediment erosion. Why is this a good idea? Well, dairy farms and almond orchards and processors are already pretty co-localized in California. If you look at the map on the right, you can see where dairy cows are in California, where dairy farmers are in California, and where the almond cultivation is in California. There's a lot of overlap. Dairies have a history of using almond hulls as feed and shells for bedding, and many dairies already practice limited composting for bedding production. A lot of dairies will take their solid manure, whether they get it from a separator, whether they get it from corral, whether they dredge it out from the lagoon, and they dry it, they do some form of composting or advanced solar drying, and they recycle that as bedding on the farm. And so kind of what we were envisioning is that you could have the shells, hull, sticks come back to the dairy. You could mix that in with the manure that's taken, the solid manure that's taken and separated, and you can compost on the farm, and then you send back some manure stick amendments back to the orchard. And so the dairy that we've been working on is Wickstrom Dairy. The solids, the manure solids that we're working with are specifically from their separator. They have a very unique separator system in California. I think there was one other dairy that was going to put this system in, but maybe not. As far as I know, they're the only one. How it works is flush water comes to a reception box. From the reception box, it gets pumped to the first two-stage coarse separators. Those are rotary drum separators. They produce coarse solids, and then the water from that goes to a sand removal tank and then a settling tank. Now, what's interesting is the water from the top 3 rungs of the settling tank goes back and is used to flush the barns, and the bottom 2 rungs has settled sludge that then goes to the fine separators, which are separated with a finer screen. And then from there, the water goes to the settling pond, then one of the 2 lagoons. Interestingly enough, they've actually just installed a centrifuge to clean the water from the fine separators even further, and hopefully get all the total dissolved solids out, all the total suspended solids out, excuse me. So the solids that we're using in this project are actually the fine solids. The coarse solids, they compost and they use for bedding. And the fine solids, some of it they use for bedding, they largely land apply it, they compost and they land apply it for the acreage that they don't have accessible from the lagoon. In terms of the problems of sticks and twigs for almond processors, well, orchard debris is on average 13% of the harvest field weight brought to the processor, which if you calculate that into 2018 would have amounted to about 9.3 billion pounds. JP, to address your question, the debris consists of dirt, pebbles, rocks, twigs, and sticks, and trash such as wood tape. So there's definitely contamination. It's dirty by nature. It's a challenge for the processors because regulation and the dirty nature of this material make it difficult to send to cogeneration plants. It has little to no value, is given away for free at best. It can take space for years and can be a fire hazard and can take money to process and have hauled away. So we went to a couple of processors to see this problem firsthand, and the level of dirtiness of this debris kind of depends on the processor a bit. It depends on the processes that they have, how much pre-cleaning they have, and how good of a job they can do at getting those sticks out. It also depends on some of the farms. It can depend on the farming practices, the field soil characteristics, the age of the orchard, and the manufacturing factors, obviously the degree of the pre-cleaning. So the picture that you see here is kind of, this is right after the pre-cleaner, and this conveyor belt is taking some sticks to separate them. You can see the sticks and twigs aren't just taken out in the pre-cleaner step, they're taken out during the dehulling, the deshelling. On the right, you can see sticks being removed from the dehulling. You see a lot of hulls in there. On the left, you see unit operation where the sticks are being flung over that wall on the left and the rocks are just dropping down. This is the example of a stick and twig pile from a processor in Ripon. The sticks are, they can get pretty big. You can see some plastic in there, some plastic bottles. There's a lot of things that come in from the orchard. There isn't a lot of motivation at this point to clean it up because there's, like I said, there's not a lot of higher value for it at the moment. These are ground stick twigs from a processor in Chowchilla. This processor actually paid to have a company come and ground their sticks and twigs and still couldn't get rid of it. But luckily for us, we used a bit of it, just a little bit of it compared to the mountains that they have in our project. And just to give you an idea of what the work plan, the timeline is for this project, it's a 3-year study. We started in July of 2019, and it's set to go through March 2022. The amendment production is for 2 seasons. The amendment application is for 2 seasons, but we're doing 3 years of field study, looking at the soil, looking at pathogens, looking at almond yield, and looking at soil emissions. To give you an idea of the process that we're working with for the composting and the pelletization. So we took dairy manure for the first year and we mixed it with the sticks and twigs, 80% by volume to 20% by volume for the sticks and twigs. By mass, it was about 90% dairy manure, 10% sticks and twigs. We actively composted for about 8 to 10 weeks. And then that gave us our treatment 1 and treatment 2, which was our manure compost and our manure stick compost. And then some of the compost, loose compost, we sent to our pelletizer, which produced our treatment 3 and 4, the pelletized manure compost and the pelletized manure stick compost. Now, in between, obviously, there was a couple of months where the compost, after we actively composted, we stored it on the farm. But after the pelletization, all 4 treatments were loaded up in an applicator and were applied into our experimental plot. And so our experimental design was a randomized complete block design. We had 5 treatments unamended, and our four organic matter amendments: the manure compost, MC, manure stick compost, MSC, pelletized manure compost, and pelletized manure stick compost. The orchard we were working with had Independence variety almonds, and we applied an application rate of 4 dry tons per acre. So to give you an idea what this looks like, step 1, you load the raw material just into a side dump, you weigh it on a scale, then you apply it in these rows. All of the farm personnel helped us with this, we didn't do it. The first year we actually added water because the manure only compost is obviously a lot wetter. It comes out of the separator at about 77% moisture, 70 to 75% moisture, maybe sometimes a little bit higher. The sticks are obviously pretty dry. And before adding the water, the mixture of the two was about 55%. So we went and we had them add water to bring up the moisture. The second year, we actually didn't do this. We just left the manure stick pile at the moisture it was and just let it compost. And then they have the turner that they gum through with every week, and they turn the piles, and that gets some aeration. We returned weekly to take measurements and samples during the 10 weeks of active composting. And during the active composting, we were measuring ambient temperature. We were also installing internal temperature sensors in the pile to see how hot they're getting. And we're also getting some samples we take back to the lab for moisture content and total solids and volatile solids. And we measure basically the bulk density and the dimensions of the pile to get an idea of kind of mass changes, combining the moisture and the total solids data with the bulk density and the dimension of the pile, we're able to get a good estimate of how the pile is changing during that active composting. And so this is kind of, you can see a side view, the 2 side views of, and the front view of the compost pile. You can see the intersection of the red and green is where we're putting the 4 internal temperature sensors, and we're putting 1 ambient temperature sensor. We're working with about 100-foot long windrows. And this is the data from our first year of composting. The manure compost started a little bit wetter, but by the end, they actually both reached about the same moisture content at the end of the the 10 weeks, we actually didn't, I'll just go back to this. We actually didn't, we saw a difference in terms of wet mass loss because, you know, there's a difference in moisture, but in terms of a dry basis and a VS volatile solids mass loss, there was actually no difference. They were pretty much the same, the mass losses between the two piles. This is the temperature data. The yellow line is ambient. We had an issue here where the ambient temperature sensor was not measuring properly, but basically the ambient temperature is the same between both piles, and you can see that the piles are getting between 60 to as high as 75 degrees Celsius. The drops are just whenever we would remove our temperature sensors, and that would, you'd see a drop. We'd remove them whenever they turn the windrows. And so after the 10 weeks of composting, we stored the compost on the farms for several months because it started raining. And then we got into pelletizing it with a lab scale pelletizer that we set up on the farm. It was interesting because we expected that the input material for the compost should be about 10 to 15%. So we were really worried about it being too wet when we started the composting. But you'll see that's actually not the case. This is the pelletizer set up on the farm. See the pelletizer, we had a bin for collection. We had a screen for screening out fines. We have a raised platform with shelf to make it easier to access. And this is kind of some pictures of what pellets look like falling into our bin, what they look like up close. This is pelletized manure stick and what they look like in the applicator. I'm actually going to briefly stop and share a video of the pelletization. So the pelletizer has a roller and a die. And we add the material in. You probably can't hear the audio because you hear my audio rather than the video audio, but you can see it's basically pressed through the die and you get the pellets coming out. And you can see this is a manure stick. And you can see the fines underneath. All right, let me just go back. Oh, no. There we go. Okay. So you couldn't make it to the farm, but we kind of brought the farm to you. So the observations that we saw from pelletization after storage, again, we had dropped moisture content down to 13%, which we thought would be ideal for pelletizing. That's what we had, when we'd previously used it to pelletize just a dried digestate in another project for another CDFA project, it had been fine. But during initial tests, every time we would run the dry compost through it, it'd plug up the pellet mill die. And we suspect part of that might be because of the sand. The soil on the area is pretty sandy. A lot of sand can blow into the compost, and so that might have been a reason why it's plugging up. It gets, hotter. That sand kind of absorbs heat, and so the high pressure and temperature of pelletization was hardening the compost, plugging the die holes. We re-wetted the compost, and we found that we could successfully pelletize it. When we got the compost too wet, the pellets become less durable. You get more fines; they're more easily broken apart. And so we found like a moisture content between 25 and 35% more suitable for pelletization, adding more woody biomass, and ideally you'd have, you know, a hammer mill or something to break down the wood even more. We had a decent amount of wood that was still, you could see the wood, it was still uncomposted. So that would be best processed if it was ground finer and then run through the pelletizer. So here's some data on the nutrient composition and bulk density of the different products. So MC is manure compost, MSC is manure stick compost, PMC is pelletized manure compost, and PMSC is pelletized manure stick compost. So we found bulk density increase for the dairy manure by about 2 times. So from the manure compost to the pelletized manure compost, about 2 times. From the manure stick compost to the pelletized manure stick, we were getting about 1.5 greater bulk density. As you'd expect, the C to N ratio, carbon to nitrogen ratio, increases when you add sticks to the amendment. So manure compost, when you have manure stick compost, it's a higher carbon to nitrogen ratio. You see the same thing for the pellets. Interesting that when you add wood, electrical conductivity drops, EC drops in half, but pelletizing increased EC slightly. So going back to our experimental design, now that we have our products, we had to apply them. And so we calibrated our applicator to apply 4 dry tons per acre. And you can see how we were doing that. We were just kind of setting up 2 trees, and we would apply, and then we would go away and see how much we were applying. And that's how we were able to calibrate this applicator. And this is just, hopefully you can see the animation. You can see the composted manure application on the left and the pelletized composted manure application on the right. So in the first year, we just applied it. Actually, this year, we did our application about a month ago, a little bit over a month ago. And we actually designed an experiment to try to quantify the broadcast, kind of the distribution of each of the products across the berm to see if there were differences. I'm not going to share that data because it's that experiment just happened. And we also have a second experiment where we're kind of checking to see over the course from now to harvest, what are the differences in the breakdown between these products, and how much residue is left at the end of the season before harvest. So these are a couple of questions that we have that we'll be answering. Looking at the NPK in the compost, the manure compost, the pelletized manure compost had pretty close 1.25% nitrogen, 0.35% phosphorus, 0.9% potassium on a dry basis. The manure stick compost, the pelletized manure stick compost had about a 1.05% nitrogen, 0.23% phosphorus, 0.75% potassium. What this translates to at the rate that we were applying to is for the manure compost and the pelletized manure compost, we were putting down 100 pounds per acre of nitrogen, 28 pounds per acre of phosphorus, and 72 pounds per acre of potassium. And for the manure stick and pelletized manure stick, we were getting 84 pounds of nitrogen, 18 pounds of phosphorus, and 60 pounds of potassium per acre for every 4 dry tons of the amendment that we were applying. Also part of the project is we're doing field measurements. We're looking at the soil and amendment quality and safety. So we're taking soil samples, we're measuring physical chemical properties. We're also measuring pathogen, E. coli and salmonella. We're looking at the tree health and also almond quality and safety. So we're measuring tree circumference every winter, well, not every winter, in February, March. And then we're at the end of the year at around harvest season, we're measuring almond yield. And again, we're doing the same. We're measuring E. coli and salmonella we're testing for them to see if the almonds have them. And finally, there's a soil emissions component to the study where we're deploying static chambers to measure carbon dioxide, methane, and nitrous oxide emissions from the soil between treatments. And so in terms of the pathogens, we looked at the 4 amendments in terms of E. coli and Salmonella, and the E. coli was measured by qPCR, the Salmonella was measured by a culture method, and those all came out negative. So that was good to see. And for the soil emissions, we did our first measurement in the summer. We took a baseline soil emission measurement 1 day before irrigation, and then we measured soil emissions 1 day after irrigation and 4 days after irrigation, where we would expect it to be higher because of the moisture. And I have carbon dioxide and N2O data here, and we found differences between the alleyway and our other treatments, but not actually between any of the amendments themselves or the unamended. The reason we suspect the alleyway deployed chambers are different, and if you can see here, this is what the chambers look like. So they're deployed, and basically we put them in, and every half an hour we're measuring a gas sample, and then we measure the gas samples by GCMS to get our measurements for CO2, methane, and N2O, and then we're calculating flux measurements from that. And so the reason the alleyways are different is because they're getting different moisture and sun than the other treatments. We place the gas chambers in a way that they would be equivalent in terms of moisture and kind of coverage, but the alleyways, there's no really way to do that. In terms of our harvest, we harvested 1 tree per microplot in August of 2020. We hand harvested, we determined the field weight per tree, we took a subsample back to lab, and then we separated the kernels, the hulls, the shells, and the field debris, and we measured the moisture content of each fraction, and we extrapolated it back to the field. Actually, I have data for that, and in terms of the whole nuts, the hulls, the shells, the kernels, we didn't see any differences. They were all pretty similar between treatments. This is on the y-axis dry weight per acre for each of those, for whole nut, hulls, shells, kernels. And so conclusions that we have gathered so far is after 10 weeks of composting, you see obviously the main loss that you see is differences in moisture between the 2 piles, but in terms of total solids and volatile solids loss, it's pretty similar. Adding wood obviously increases the seed to end ratio as expected, but it decreases the EC of the amendment. For pelletization, 10 to 15% was too dry for compost pelletization, but 25 to 35% was a good range. We were successfully able to pelletize both types of compost. Pelletization increased bulk density between 1.5 and 2 times and slightly increases EC. For application, higher bulk density means that more pellets can be loaded into the applicator and you can have less trips. We successfully were able to apply both the compost and the pellets at the rate that we wanted, and we found out how much NPK we were applying between the products. For the year 1 harvest and soil emissions, we didn't observe any differences in yield between treatments, and we didn't observe differences in soil emissions for carbon dioxide and N2O. Methane data is still being analyzed. And in terms of pathogens, the amendments tested negative for Salmonella and pathogenic E. coli. And so ongoing and future work, we've completed the first the year 1 and year 2 compost experiments. We've completed year 1 and year 2 pelletization. We still have field work, soil and pathogen sampling that's ongoing. Our year 2 harvest is set for August, September 2021, and we'll be measuring spring measurements for soil emissions shortly. Our amendment application for the first and second year is over, but again, as I mentioned, we did a broadcast kind of catch experiment, which I didn't present, but basically we're looking at what's the amendment broadcast distribution from the applicator. We collected the data. We're still analyzing the data, but it's given us some pretty interesting results. We're also conducting a residue experiment to see, again, how much the amendments are breaking down, if they're breaking down differently, and to quantify residuals at harvest. So I just want to acknowledge all of the sponsors and the farmers and our collaborators again. Thank you for all your help. And that's it for my presentation. Thank you very much.
Thank you very much, Hossein. Fantastic research and presentation on behalf of our research team here. And also, we do have a second research presentation. I wanted to introduce our next speaker. Next speaker is Dr. Sat Danshan and Kelsa. And Sat is assistant professional researcher in the Department of Plant Sciences at UC Davis, and his research focus has been on nutrient recycling and the management in tree crops, integrating plant, soil, social sciences. And Sad has been a great member of our research team and has been advising, working with us on the application of compost products in the orchard, and also soil science research. So soil, tree, and nuts research. And Sad, are you ready to go? Good.
Yes, I am. So thank you, Dr. Zhang, for having me here today and in inviting me to be a part of your research team. And welcome everyone. If you came here today to learn more about compost and how it's made and used in orchards, then you're definitely in the right place. So what I wanted to do was, as this project, this research project in particular is ongoing, what I wanted to do is present some of the results that I've developed in collaboration mainly with my mentor, Patrick Brown, in the Department of Plant Sciences, and show you kind of what we know now, like what have we learned about compost use in orchards, but also bigger picture, what do we know more about how carbon and nitrogen cycle within orchards as well? Because really, when we're talking about moving manure products from dairy farms into orchards, there's lots of implications for agronomic value, for benefits to environmental quality, but there's also lots of potential regulations that we have to be aware of. One being related to storage of carbon and the benefits associated with that, but also understanding what implications they have for irrigated lands and nitrogen use. So I kind of want to put as what we know now into a big picture for you all today. So again, my name is Sat Darshan Khalsa. I'm in the Department of Plant Sciences. And my presentation overview today, I'm going to talk about Dr. Brown and I did a grower analysis of almond growers throughout the state about their use of organic matter amendments. What are their concerns? What's the availability? And our colleague Denise pointed out that there are some concerns associated with manure or dairy manure. So I wanted to talk a little bit about that from the almond grower perspective. I also want to touch on orchard cycling. And when I say cycling, I'm talking about carbon, nitrogen, and kind of what we did with a larger study in orchards to understand how there's this interaction between carbon use and carbon benefits and storage, and how that's implications for nitrogen use. This study was not done with compost, but it allows us to think holistically about how we can then use compost and what their implications are for our industries in California agriculture. And then lastly, I'm going to give a preview of a study that I initiated before this study, where we have some more finalized results focusing on nitrogen. What are some of the composted practices that were used that were then replicated in what we did here with Dr. Zhang and her lab group? And then what do we know about how nitrogen in particular is balanced within orchards? So first, I want to sort of highlight this concept of barriers to adoption. If we want to be able to use organic matter that is seemingly abundant in the state of California, not only from dairy farms, from almond stick and other sources, but also from yard waste and urban sources and green wastes, we have this abundance of materials that can be used as organic matter. But what we wanted to know from the perspective of orchard growers, almonds in particular, what are some of the barriers to adoption of using these materials? What are your grower concerns? So first and foremost, it was food safety is a major priority. As many people on this call know, that almonds are harvested off the ground, and any contact with almonds and compost, which of course is surface applied, no till, it's not typically tilled into the soil, that any contact with that could create any food safety implications. And that was a main concern and a priority for growers. And I have to congratulate our lab group, really, because we really addressed that by showing that we can, with proper composting and proper application and maximizing the time between application and almond harvest, we can do this work in a food safe manner. We also did, in this graph here, we're showing on the tops are users of compost compared to non-users of compost. So when we did the survey, we asked if you were a user or a non-user of compost. And interestingly enough, non-users are the ones that have a higher concern for cost and logistics. And that makes sense. If you're using compost, you most likely have a better sense of how to do it and what's the cost associated with doing it. But when you're not using compost, this ideas of cost and logistics become a challenge, and maybe you don't have the proper equipment, for example. But for users of compost, after that concern of food safety, then we started talking about nutrient availability. What value am I getting from it from an almond grower perspective in terms of nutrients? When you ask about carbon storage and those types of questions, for growers, that isn't a major priority. But I know as an industry and as California agriculture as a whole, we're also thinking about that within the context of healthy soils. We also asked these growers about quality and availability. So I want to say up front here, and we know as a group here that manure, as Hussein had showed, is a huge opportunity. When we look at the San Joaquin Valley in this study, there was a high ratings of excellent or good to excellent availability or accessibility of manure. So, and this is a lot where a lot of the almonds are being grown. So we have this partnership between farmers potentially and almond growers who are neighbors. And we modeled that here in our study for you all. So we definitely have evidence that shows that. When it comes to green waste, which is another good source of compost, it's not as available all around, but it tends to be certified and a little bit more consistent in its quality. But when it comes to it being more centralized production, you have the questions of transportation costs. So again, I think the partnership with the almond board and the dairy industry we did with this project is really leveraging this really important opportunity about abundance and availability, and thinking about how we can produce compost on dairies that has consistent quality and value. And lastly, a lot of the technology we showed, not so much on the dairy side, but in terms of once the products are created, getting it out into orchards tends to be fairly simple. I mean, we're talking about spreaders and other types of material to get it out into orchards. So technology doesn't seem to be a huge barrier to adoption, but of course, what is always a barrier is having good information and the right partnerships, and also really communicating with our industries about how this is really a long-term investment. And I like to say to almond growers, it's a long-term investment, just like your trees. You know, you're growing your trees for 20 years or so, so you have to think about it in the long term. So I just want to take a step back for a moment and think about orchards and how there's a connection between carbon and nitrogen and how it's cycled. So this was a larger study that I just finished last year, where we look at these interactions of how nitrogen and then carbon cycle within orchards and how they're intricately linked. And so we did a study with 15 nitrogen where we looked at applying it to an orchard. And what we wanted to understand is, what are the roles of soil organic matter within an orchard? So when we applied 15 into an orchard in the first year, we find these large pools of nitrogen stored in the trees and then also in the soil organic matter. And then over time, what we see is there's a large accumulation of nitrogen in the crop, and there's a decline in nitrogen within the trees. And at the same time, we're seeing releases of nitrogen from the soil organic matter. And the reason I'm showing this is this can be modeled with what we're doing with compost. If we're going to be building soil organic matter, we're also going to be building nitrogen. They go hand in hand. It's hard to build soil organic matter if you're not also applying nitrogen to the soil. But what we understand fundamentally, though, is after 5 years, as that soil organic matter released, the nitrogen started to release, it actually started after 5 years increasing again, all the way 5 years later, all the way to the same level that it started in. And what this is showing is that it's just a model that shows that orchards cycle nitrogen through the system very much like we'd expect a deciduous forest to do. And what we want to do now is start thinking about how we can then introduce compost and other types of materials to sort of leverage that cycling and that balance like we would in a natural ecosystem. So what we did with this particular study is we linked nitrogen use with carbon cycling, and we had 2 different rates of nitrogen fertilizer. And I converted all these units to metric tons of CO2 per acre per year. In the paper, everything's in kilograms per hectare per year. So I did some conversions here for use. And what I want to show here is that almond orchards in particular are a really important opportunity to continue to intensively farm and produce commodities that are important, but at the same time, balance it with the potential to still store large amounts of carbon. And in this particular study, we were just doing this without the use of compost. But now that we have the uses of compost available to us, we can see that this is a large opportunity. So when we see these changes in soil organic matter over time, that we see that there's a larger increase when we apply more fertilizer and more intensively farming. And then when we offset, and what happens is that change in soil organic matter really offsets any of the nitrous oxide emissions. So when we see higher nitrous oxide emissions, then we start to see that the change in soil organic matter is really what's driving that offset. So when we're building soil organic matter, that we might not have nitrous oxide emissions, those emissions are really going to be offset by building soil organic matter and soil carbon. What we found over time is that net global warming potential was significantly lower when we used intensive fertilizer rate, and that we were still able to store carbon within the wood of the almond trees. So lastly, when we look at the net CO2 storage in the orchards, the increase of intensive farming driven by no tillage and tree wood was what drove higher storage of carbon within the system. However, I have to make a caveat that a lot of that came at the cost of nitrogen losses. We did see higher nitrogen losses to the environment, and that was really driven by higher nitrogen use. So this higher nitrogen use was able to allow us to store more carbon. So we want to think about the balance between the two. So that leads us to this question about what happens if we can start substituting some of the nitrogen inputs with compost. So in my last few minutes here, I just want to give you a preview of another compost trial we did in almonds in San Joaquin County in 2015 and 2016. We had a grower control where no compost was applied and a compost application rate that was similar to what was done in this study. And what we did here is we used composted manure that had a lower CDN and green waste compost, which had a higher CDN. And what you can see here is how almond growers are really applying compost is as a surface applied mulch underneath the irrigation system. So that concentration of material on the berm is really how growers are applying compost in these systems. Some of the measurements we did in this study were similar to some of the measurements that we're currently doing. We looked at a release of nitrogen from decomposition, but in this particular study, we're focused more on nitrogen. We wanted to understand what's the availability of inorganic nitrogen from compost. And then we also want to understand how we're changing the total nitrogen in soil organic matter. So in this paper that's currently under review, we use this technique of measuring nitrogen availability using ion exchange cores, where the water can pass through the core and then be collected at the base of 50 centimeters, which is typically within the root zone of young almond trees. And using that technique, we were able to measure what was essentially the available nitrogen from the compost that was applied. What we did, we had a little bit lower CDN ratio. So what we applied was about 130 to 170 pounds of nitrogen. And what we found through decomposition, that 75 to 85% of the material is released. So we're able to get this material to break down and those nutrients to become available within the root zone. When we measured net N mineralization, which essentially how much nitrogen from that compost became available in that one season when it was applied, our numbers look like this. As we increased the CDN up to 18, the availability started to become lower and lower. In fact, all these availabilities are less than 10%. So then we have to take a step back for a moment and start thinking about, if we're applying this much nitrogen, I think Hussein alluded to about 100 units, we're only going to be expecting less than 10 of those units within that particular growing season, right? So then what happens with the rest of the nitrogen? Is it being lost to the environment? Well, no. In the techniques that we were using, we measured the change in total nitrogen in the soil organic matter. Again, if our goal is to be building soil organic matter, we want to know what the change in nitrogen as well, in addition to carbon. And as we increase the CDN ratio, what we saw is that over half to 2/3 of what was applied in these 12 to 13 CDN was captured within the soil organic matter. So that will either need to stay in that system in order to stabilize carbon if we want to continue to stabilize carbon within the system, or it's going to be released in subsequent years when the orchards are continued to be farmed. What we found, which was interesting, is that when you get to a CDN that's around 18 or so, we were able to capture more nitrogen than we actually applied. What does that say? Is that likely some of the fertilizer nitrogen that's being injected by the grower is being immobilized by the carbon that's being applied. So we do have to circle back to, what was that secondary concern that orchard growers have after food safety? Well, for them, it's nutrient availability. Are these nutrients going to become available? We have some evidence that shows when they will. But secondly, when we apply these materials, are these materials going to interfere with the nutrient program that I already have in place? And there's been decades of research done, led by Dr. Brown and others, that have shown and have helped us establish how much nitrogen or how many nutrients are required in orchards, and what are the 4 R's and how to apply it. And we start bringing in organic matter and other types of things. We have to take we have to question closely, how is that going to interfere with the nutrient program, even if we're able to show that you can increase soil organic matter. So it's not I'm not putting a pause on this research in any way. I just want people to recognize that there are some important trade-offs that we need to be aware of when it comes to building carbon and making nutrients available for intensively farmed crops like almonds. So just a brief summary here as I wrap up. I touched on these barriers to adoption for almond growers, about nutrient availability. What's the availability for different organic matter sources? What are their different trade-offs here? I think in particular, this group and our group has done a great job at being able to produce high quality manure products that are safe and that can be used by neighboring almond farms. We need to also continue to think that when we're building carbon, we're also having intricate links with nitrogen within the system. And these orchards really do cycle like forests over perennial time, right? We need to think about this over the long term, not just what can we get out of the system this year. As researchers, we need to think about that, but also within the context of growers, we need to also think about not only the annual cycle, what's going to happen this year, but what's going to happen over the future, and how the rates of different applications of nutrients can impact this balance between carbon and nitrogen. What are those trade-offs, particularly around nitrogen losses? And lastly, what we've learned so far with additions of organic matter is that at this time with compost, we can't really expect more. We would likely expect less than 10% of the nitrogen in that compost to be available in the first year. What happens in subsequent years is what we're continuing to research. But at the same time, the other 90% isn't lost. We haven't lost this material. We've invested it over the long term. And I've documented about half or 2/3 of that was easily detected in the soil organic matter. So what do we do with that material in the future, and how it's farmed is an interesting research question that I hope to continue to pursue. So here's some references on the papers that I presented today. And I want to acknowledge the Almond Board of California and CDFA, as well as USDA, FAR, and many, many colleagues at UCANR who've really helped bring a lot of this almond research to you today. So thank you all, and I'm happy to take questions.
Thank you, Asad. You really point out the importance of research applying these organic amendments in orchard and other crop fields, and also stress importance of long-term research, long-term benefits. So it will show up over time. And so we are really good at on the schedule, and now is a good time to answer some of the questions posted in chat, and also if our audience has questions, and this is a good time to open up for Q&As and also discussion. And I have seen a couple questions, and one is from JP, and Jose answered in the chat, but maybe this is a good time to bring that question to to our panel here. So let me see. JP, thank you for asking questions and also listening and working with us. And the JP is a great supporter of our research, actually helped initiate this project. JP had a question for, okay, where's the question? Was there baseline taking for soil quality parameters? Okay, for example, soil water holding capacity, soil carbon, and if so, were there any changes over time in soil quality measured in, in the treated plots? And Jose answered the question in the chat, but Jose, are you there? Do you want to just answer one more time?
Sure. Yeah, my response was we took baseline soil samples of the plot in October 2019 before any amendments were applied, and then we took amendments samples again in March 2020 and in August 2020. So we're sampling the soil every 6 months. None of those samples have been analyzed yet, but they're sitting in lab, and hopefully we'll have that data for you in the next field day.
And to JP's point, we have those baseline samples, and as the project wraps up the end of this year, after 2 years, I suspect we'll do a more of an intensive sampling campaign. And with that, we're able to show what is the status of the soil after 2 years of amendments. And then we'll have those baseline numbers to be able to quantify what the changes were, in fact. So we can get to numbers like I've shown, how much nitrogen was applied, how much is in the soil organic matter, and more importantly, how much carbon was applied and how much carbon was still present in the soil organic matter. So to the audience, we need to balance what is the agronomic value of nutrients becoming available and taken up by trees, and what's the value of keeping those nutrients stored in the soil. And I think there's still a balance there that we haven't clearly identified what it is. But I encourage everyone on this call to be thinking about those things with your research or the growers you work with. Where can we find this balance between agronomic value and environmental quality?
Okay, thank you for answering. And yes, so we still have lots of samples sitting in the freezer, and it has been extremely difficult year for us. And our research team have done a fantastic job following the safe health protocols while still being able to carry out the most research activities on the farm. But because of restriction to lab facilities, we still have lab samples stored in the freezer. We'll be analyzing those, including the soil samples, and making the data available. And hopefully next field day, when you come back, we gather together, we'll be able to present the results related to those analysis. And
so there's a question from Muhammad Siddiqui. I think it's probably best suited for Dr. Satarshan. Can the plant and leaf N or protein be used as an indicator of nitrogen losses and ultimately for adjusting nitrogen application rates?
Yeah, so Mohammed, a good question. What I found in other compost studies is we have not actually seen a significant difference in leaf nitrogen levels between our treatment and our grower control. Now, remember, the grower control is still being fertilized. We don't have any unamended controls yet. I hope to work with our other site to convince the grower that if he does not fertilize these sets of trees, we can get better information. And that's always a hard sell for any private operator. But because of those low availability numbers, that margin to be able to create a significant change in leaf nitrogen has not been shown. So I can't in confidence say that the nitrogen is being taken up in a different rate. But I can say that it is still present in the soil organic matter, at least at this stage. We have more data that's been collected over many years. But at this stage, where we typically look at nitrogen use efficiencies as a partial balance, what we can detect in the tree and what we cannot detect as potentially lost, I want to stress my fellow researchers and other researchers, as well as potentially regulators with the state of California on this call. Just because we can't find it in the tree right away doesn't mean it's lost to the environment. And I hope that slide I showed full evidence that if it's stored in the soil organic matter for nitrogen, that it's still there. It's just we haven't decided what's the value. Do we want to use it for the tree, or do we want to continue to store it in the soils?
There's another question I think that I could address from Ryan Flaherty about why we suspect pelletization increases EC. And I mean, so pelletization is introducing pressure and temperature. So, I mean, my thought is that we're burning some of the volatile solids, but you're not losing any of the fixed solids, right? The salts, the minerals are still there. So that could potentially be why it's increasing EC.
If I can also add to that the answer, and I don't think we are increasing by mass, and definitely concentration, because we compress, right? It's a pelletization, compress the material into higher density. So the concentration, there's increased concentration, and but then not the increase of the mass. But the Hossein just stated, there's a bit loss of volatiles, and that may be a factor, but the increase should not be significant for the salinity or EC. Okay, so then there is a question. Let me see. Okay, Hossein, do you want to read out the question from Ryan?
There was JP was wondering if the slides could be made available afterwards, and I guess we'd check with the speakers and see if it's okay with everyone, and potentially make them available. We're still figuring out where to post the recorded video for this, so we'll communicate that when we know it.
I have a question for Aaron, if he's still available to answer questions. I wanted to know, Aaron, for you, how much excess dairy manure do you have on farm that can be utilized as for compost or other products for use on other farms? Do you, in your view as a dairy operator, are these materials, like, is there abundance of them and you have this opportunity to add value and use them on other other farms? And if so, is it a large amount, or there's like a margin there that you're operating on?
I think a lot of it depends on individual farm situations. For us, with the amount of farm ground we do farm, we could use 100% of it on our own ground for triple cropping and our row cropping operations. A good portion of it for the bedding in our freestall barns, we do use composted manure as the bedding. It's a nice soft comfortable medium for the cows to lay down the beds that is relatively pathogenic free. So it depends. We've made a priority. We look at creating our own compost, whether it's for sale or going to almond orchards or on crop ground, is kind of a hedge against commercial fertilizer prices to a degree. So that's kind of how we look at it. So we try to divert as much as we can for fertilizer use.
So would that be safe to say that if there was value for your enterprise to create a manure products and that was profitable for you, wonderful. But at the same time, would that then increase your reliance on commercial fertilizer for triple cropping? I mean, that's pretty intensive farming of ground, and I understand why, you know, you need that feed for your cows.
Yeah.
I'm wondering if that's if there's a potential increase in your reliance then on fertilizer.
Yes, yeah. If we diverted it off our own ground, then yes, it does increase the reliance on commercial fertilizers for those row crops. It does.
Yeah, for your particular farming situation.
Yes, exactly.
Cool. Thank you for sharing that.
No problem.
Okay. Okay. Yeah, there's a question from Ryan, and we'd be interested in any water-related outcomes, filtration, water retention, nitrogen immobilization, cycling, any of the research presented.
Yeah, Ryan, I can speak. In that same study in San Joaquin County, we applied composted manure. And after 2 seasons, we saw significant differences in water holding capacity from applying compost. We also saw significantly higher soil moisture using a neutron probe. And although not significant on the same trees, we saw lower tree water stress. And that's a different publication that I could share with you. So we have some information on at least water. We don't have information on if you increase soil organic matter and then manage your irrigation differently, how would the trees respond? And I would say that's another interesting study that could be looked at in the future.
Okay, thank you, Seth, for answer. And there's a question from JP. And given the difficulties with the composting, especially air quality permits in the San Joaquin Valley, do you think it might be possible to make pellets, manure or manure mixture with the wood without the composting step? Okay, I'll be happy to answer that question. Others can chime in. And
Rayhong,
yes.
could I just add to my question, because I left out an important thing we recognizing that we still need to have pathogen kill. So can we get the pathogen kill and also skip the air quality permitting, or is that just not technically possible? Thank you.
Yeah, so pathogen is important. Certainly composting, especially raising the temperature during the composting process and can destroy the pathogens, and biological safety is very important. And also just looking, to answer your question, yes, definitely we can pelletize manure without the composting. And I just needed to make sure it's pathogen free and also weed seed free. And but the one benefit I see from composting is that composting does reduce the biological active carbon. Okay, so easily degradable carbon, basically make the compost products more stable. Carbon in the compost products more stable. And so I guess depending on the need for farms, the soil, and certainly have less BOD loaded into the soil, there's a benefit to it. So carbon in this organic amendment and become more stable carbon rather than fast degrading carbon, which could cause some oxygen demand problem for the soil. So I think composting certainly has unique benefits compared with the manure, just the uncomposted and raw manure, for example. Yeah. Others can chime in.
I want to make a comment that I didn't have in my presentation, just about potassium. And this is kind of just speaking to Aaron again as the dairy operator. Almonds use per unit more potassium than nitrogen, believe it or not, or maybe you did know that. So I'm wondering if I saw the potassium levels for the products that were created were decent, but is there more potential to leverage potassium sources on a dairy by the way that the lagoon or the flush water is diverted, so that we could extract more potassium potentially and then have that show up in a manure product? That would certainly add value for growers where they're facing high costs for SOP, and inexpensive potassium chloride is just not able to be used in orchards. So I see this as a huge opportunity where dairies are not only producing nitrogen, carbon, but also potassium. But I understand it's the way that it's flushed within the dairy that's how you can get that into that, you know, the manure stream for a potential product.
Yeah,
I would like
interesting in the current project we're working on right now with the addition of the centrifuge. Once we get samples back on that, I think it'll be interesting to see if we're capturing more of that potassium now that we're taking out pretty much all the solids within that nutrient stream.
Yeah, and I wonder, same question about the nitrogen, if would that increase your reliance on potassium fertilizer for your triple cropping, or is the potassium demand by nut crops that much greater that there could be a net benefit to California ag as a whole? So this is a big picture question to think about. You know, if we're just diverting it from one ground to the other ground, you know, there could be value there certainly, but on a larger net basis, if I don't know the K demand of silage crops, maybe it is lower in fact, and that could be used elsewhere for nut crops to add value. So anyways, just something to think about.
Okay, thank you. I think we have 10 minutes to go, and we'd like to conclude our Q&A session so we can have another survey to go. But if you have any more questions, so you can put in the chat, and next few minutes, now we can answer those. But for now, there is a post survey. Hossein has launched. Hossein, do you want to say?
Yeah, so we had a pre-survey. We kind of want to know who you were and what brought you to this field day. Now we're going to launch another poll or survey, and we would like to see what you learned. It's not a quiz. It's for our purposes to see what we were able to convey from this field day. So please take a minute to respond to the poll. You should have a pop-up that opened up with the poll questions. There are 6 questions. Looks like we're just halfway there. 22 of 39 have responded. Okay, I'll leave the poll going in case we get more responses, but I think Dr. Zhang, you can continue and wrap us up.
Okay, well, thank you. Yeah, please respond to the survey and appreciate your support. And so, well, I wanted to thank everyone for being with us in this virtual field day, and it has been great success. And so again, I wanted to thank the sponsors for our research, California Department of Food and Agriculture, Almond Boards of California, and California Dairy Research Foundation, and also all the researchers, collaborators, and other personnel who have been great carrying out the research and also providing all the support for our research in Denver. This is a very important project, as you see, and very challenging, especially this past year has been extremely difficult. But we have been able to carry out the research safely and achieving our goals set out for the research for the project. And I really see this is a great example of partnership built between among public, private, and the agencies, and also this we're hoping, and we see this, our research has strengthened the alliance between two big agriculture industry and the dairies and the almond industry. And so we really appreciate all the effort that has been invested in this research. And as we stated before, and our research is still ongoing, and for this healthy soil project, and we have 1 more year to go, and we'll be doing a lot more measurements and in the field, and hopefully we can get to lab and yeah, have more access to the lab next few months, and then we'll be able to analyze the samples we saved, and then we'll have data, and we're hoping and planning to have a field day in the fall, and actually we're planning to have 2 for this project as the time allows. So with that, I wanted to thank everyone for being with us today, and if you have, we still have a few minutes. If you have any remarks, please feel free to speak up. And that's our survey, post the field day survey still going. Hossein, we will conclude when you close the pool.
Okay. It looks like we've had several dropouts. So we're at 30 of 33. I think I'm just going to end the poll now.
Okay.
Okay.
Again, thank you everyone, and stay safe. We'll see you next time. And also, if you do have questions, please email me or Hossein. And also, we will, yeah, we will figure out where to post our field day, and also we'll talk to speakers, and we will make the presentations available as we can. Thank you.
Thank you. Have a good day.
Bye.
Thank you, Dr. Zhang, and the entire team. Great presentation and great work. Thank you so much.
Thank you for attending, Denise.
Thank you for your
Thank
support.
you. And thanks for your support.
One way and others.